You know that fizz when you open a can of soda? What if I told you that same exact science could explain one of the most feared dangers in diving? Today, we're diving deep into decompression illness. You probably know it as the bends. We're going to break down what happens when the human body comes back from the high-pressure world of the deep a little too fast.
So let's start right there with that soda can. Inside that can, a whole bunch of carbon dioxide gas is dissolved into the liquid, totally invisible because it's being held there by pressure. The second you pop the top, you release that pressure and poof, the gas has to go somewhere so it rushes out and creates all those bubbles. Now just imagine that same exact process, but it's happening with nitrogen gas inside your own body. That's really the core danger we're talking about.
Now, this dangerous fizzing that can happen inside the body, it isn't just one single condition. It's actually a whole group of problems, all caused by gas bubbles forming where they really shouldn't be.
And the official name for that group is Decompression Illness, or DCI. You can think of it like an umbrella term that covers two different but related conditions. In both cases, gas bubbles are the bad guys. But as you're about to see, how those bubbles get there, well, they have two very, very different origin stories.
Okay, so let's get into those two pathways. How exactly does this invisible enemy, the gas bubble, actually launch its attack on the body? So here's the absolute key difference. Decompression sickness, or DCS, is kind of a slow burn. It's that soda bottle analogy. Gas that dissolved into your tissues while you were deep under pressure slowly comes out of solution as you come up, forming bubbles from the inside out. But an arterial gas embolism, or AGE, that's a sudden, violent event. Think of it like a balloon popping. Expanding gas literally tears lung tissue and forces bubbles straight into your arteries. And the timing tells you everything. DCS might take minutes or even hours to show up. AGE, it hits almost instantly. For DCS to even happen, your body has to be in this state called supersaturation. It sounds complicated, but the idea is actually really simple. It just means your tissues are holding way more dissolved nitrogen than the pressure around you can keep locked in. So just like that sealed up soda can, your body is literally primed and ready to start fizzing. On the other hand, the trigger for AGE is something called pulmonary barotrauma. And this is a straight-up physical injury. If a diver holds their breath while coming up, and we're talking even just for a few feet, the air trapped in their lungs expands. If it expands too much, it can tear the delicate lung tissue, and that tear creates a direct highway for gas bubbles to get forced right into the arterial bloodstream, where, you guessed it, one of the first stops is the brain. So we know where the bubbles are coming from, but what kind of damage can they actually do once they're loose inside you? Well, the effects can range from, just annoying to permanently disabling or even worse. Let's start with the more common or so-called mild symptoms of DCS. The absolute classic sign is a deep, aching pain in a joint, like an elbow or shoulder. In fact, that's where the name the bends came from. Old-time construction workers would get it and be bent over in pain. You might also see skin rashes, feel incredibly tired for no reason, or get weird tingling sensations. And listen, even though these are called mild, any one of them is a huge red flag that you need to get help fast.
But things can get much, much more serious. DCI can attack the central nervous system. If bubbles get into the spinal cord, you could be looking at weakness or even paralysis. If they hit the inner ear, we're talking extreme, debilitating vertigo. And if those bubbles make it to the brain, the symptoms can look exactly like a major stroke. These aren't just warning signs anymore. They are absolute, life-threatening medical emergencies.
And this brings up a really fascinating question. We know that tiny bubbles in the veins after a dive are actually pretty common, and most of the time, our lungs just filter them out, no problem. So, what's the difference? Why do those bubbles sometimes manage to cause such devastating neurological damage? Well, the answer often lies in a surprisingly common little quirk of our anatomy. A lot of the time, the culprit is a heart condition called a patent foramen ovale, or PFO. And get this, about 1 in every 4 adults has this. It's a small, flap-like opening between the heart's upper chambers, a leftover from when we were in the womb. For most people, it's no big deal. But for a diver, it can act like a secret passage for bubbles. Here's what happens. Bubbles form in the veins. They travel to the right side of the heart, where they should get pumped to the lungs to be filtered out. But if you have a PFO, those bubbles can slip right through that little hole to the other side of the heart, completely bypassing the lungs. And from there, they're in the arterial system with a direct, unfiltered shot straight to the brain. Okay, so knowing all of these dangers, how do we actually fight back against the bubbles? Let's talk about how to prevent this from happening and what to do if it does.
So no surprise, prevention is everything. The biggest risks are the ones you can usually control. Following your dive tables, not going too deep for too long, and especially not coming up too fast. Flying too soon after a dive is another big one. The lower pressure in an airplane cabin is just another form of decompression. But then there are other factors, like being dehydrated, getting cold on your ascent, and having one of those shunts like a PFO. They all add up to your personal risk profile on any given day. But if you even suspect DCI, the first aid you give is absolutely critical. First, get the diver lying down flat. Second, and this is by far the most important step, give them the highest concentration of oxygen you possibly can. Oxygen does two amazing things. It helps physically shrink the nitrogen bubbles, and it creates what's called a pressure gradient that helps wash out all that excess nitrogen from their system. And of course, call for emergency help immediately.
The definitive, gold standard treatment for DCI is recompression in a hyperbaric chamber. It basically reverses the problem. First, by increasing the pressure around the person, you physically squeeze those dangerous bubbles, making them smaller and less harmful. And second, having the patient breathe pure 100% oxygen under that pressure maximizes that washout effect, helping the body get rid of the nitrogen as quickly as possible. And that brings us to the most important takeaway: urgency. As Dr. Simon Mitchell, one of the world's leading experts on this, says, the window for ensuring a good outcome may be measured in minutes rather than hours. The clock starts ticking the second that diver hits the surface. Every single minute counts. So we'll end on this really fascinating mystery. Studies have actually shown that the same exact diver, doing the same exact dive profile, can produce a ton of bubbles one day and almost none the next. And that tells us that beyond the simple physics of it all, there are all these other complex, invisible factors at play. Things like hydration, inflammation, maybe even what you ate for breakfast. We're only just beginning to scratch the surface of understanding it all. It's a really powerful reminder that every time you go for a dive, you're not just exploring the ocean, you're exploring the incredibly deep and still very mysterious frontiers of your own body.